Hello everyone. In this video, I am going to tell about plotting the Bode plot. Let's begin the Bode plot with this equation. Let's take this equation, that is g of s into h of s is equal to 30 divided by s plus 1 into s plus 5. The first step is rearranging the terms to get the terms in standard format of 1 plus s into t. So g of s into h of s will be equal to 30 divided by s plus 1, and second term you can check, this is s plus 5. So take 5 common, rewrite the equation as s by 5 plus 1. In the numerator we have the value of k as 6. Now let's see the equation. So this is the value of k. In the denominator we have 1 plus s and 1 plus s divided by 5. So to plot any graph, we need to know the starting point of the graph. So that is why we need to find out the magnitude at the origin. So that is nothing but 20 log of 6, which gives you 15.56, which is nothing but almost equal to 16 decibel. As k is constant, slope of k will be 0 decibel. Now taking the denominator term, which is nothing but a pole, 1 divided by s plus 1 and 1 divided by s by 5 plus 1. Comparing it with the standard equation, that is 1 plus s into t, the value of t will be equal to 1. As this is the first corner frequency, let us name it as t1. So we get the value of omega c1, which is nothing but the corner frequency, which is inversely proportional to time, which is equal to 1. In the second pole, we can see that we have the equation 1 plus s by 5. Comparing the equation with standard format, t2 will be equal to 1 divided by 5. So the second corner frequency will be inversely proportional to time, which is nothing but 5 radians per second. Now these are the values at which point the slope must change. But what is the slope? We'll find out from this table. So we have a table wherein first column is pole and the second column will be corner frequency and the third is slope and then the total change in the slope. So let us take the first pole, that is 1 divided by s plus 1, and we have already found out that the value of the corner frequency is 1 here. So I'll take the same value. Always remember the slope of the poles are minus 20 decibel and the slope of 0 is plus 20 decibel. So accordingly, because it is a pole, I'll take it as minus 20 decibel. So already there was no slope before this. So the total change in the slope will remain same, that is minus 20 decibel. And then coming to the next pole, we have the corner frequency as 5. We have already got it from this. And again it is a pole, so we are taking it as minus 20 decibel. But what is the total change in the slope? We already had minus 20 here. Now one more minus 20 has got added. So both together will make minus 40 decibel slope. Now coming to the phase plot analysis, which is the second part of the graph. So replacing s by j omega. So let's see what is the equation we had. Now looking at this, 6 divided by, replacing s with j omega, it becomes 1 plus j omega into 1 plus j omega by 5. Now we need to take only the angle for phase plot analysis. So that is why let us check the angle. So converting this equation in polar form, 6 becomes 6 at an angle 0, and in the denominator we know that converting to polar form we get a magnitude and angle. So let me assume that r1 at an angle theta 1 is the polar form for this particular equation. And similarly the second one, let us assume that r2 at an angle theta 2. So now when we simplify it in polar form, the magnitudes are simplified directly, that is 6 divided by r1 plus r2, and then in terms of angle we have 0 in the numerator, and the denominator angle when shifted to numerator takes minus sign, so it becomes minus theta 1 and minus theta 2. So we already know that theta is equal to tan inverse of y by x and r is equal to square root of x square plus y square. So now based on this, let us take only the angle for the equation. So this becomes angle of g of j omega into h of j omega is equal to So we have 0, and now theta 1 is nothing but tan inverse of y by x. So wherein y is omega and x is 1. So I will replace it as omega by 1, and minus theta 2 is nothing but tan inverse of, again, omega by 5 is y and x is equal to 1. So that becomes omega by 5. This is the table for phase plot analysis, wherein the first column reads the x-axis, which is omega in radian per second, and then this gives the values of resultant adding all the angles which are present in the equations. Anything added with 0 remains 0, so we need not include it in the table. So going with the second term and third term, so tan inverse of omega, so randomly taking the x-axis as different values and see that the corner frequencies are included here. Now taking the reading of 0.2 minus tan inverse of 0.2 will give you minus 11.31, and minus tan inverse of 0.2 by 5 will give minus 2.29. Adding both of the values, you get it as minus 13.6 degree. Similarly, doing it with 1, that is minus tan inverse of 1 is 45 degree, and minus tan inverse of 1 divided by 5 is minus 11.31. Adding both of the values, we get it as minus 56.31. Similarly, finding it for all the remaining values. Now you can see that the last reading shows that the omega value is infinity. This is because I have tried with 20, then 100, then 1000, then 2000, 10,000. Checking the values, I can see that the addition of all the readings will not give me 180 degree values, that is minus 180 degree. So it will be closer to minus 178, 179, 179.99. So but it doesn't reach to minus 180 degree. But to find out the values of gain margin, we need to cross the minus 180 degree line. When the values keep varying and it doesn't reach to minus 180 degree, we assume that the gain margin will be equal to minus 180 degree at some point of omega, which is equal to infinity. So this is the magnitude plot. Let's see how to plot it. Let's go with the table. We'll start the graph at 16 decibel, which is nothing but 20 log of 6. And you can see that the constant k has a slope of 0 decibel. So we are drawing a straight line at 16 decibel until it reaches the first corner frequency of the pole 1 divided by s plus 1. So after 1, we have a minus 20 decibel per decade slope. So I am going to draw a minus 20 decibel per decade. So before that, we'll see how to draw the 20 decibel slope, that is minus 20. This is known as 1 decade, right from here to here. 1 unit in x-axis, 1 decade, and 1 unit in y-axis, that is 20 decibel. Joining the corners of this will give me minus 20 decibel per decade. Similarly, 2 unit in y-axis and 1 unit in x-axis joining the corners will give me minus 40 decibel per decade slope. And similarly, taking 3 units in y-axis and joining the corners of each other will give minus 60 decibel per decade. These are the slopes of lines. Now, I have already put it in rough. You can see the dotted lines here. This is minus 40 decibel and this dotted line is minus 20 decibel per decade. So, let me draw a line which is parallel to minus 20 decibel per decade. I'll start it from 1 and I need to continue this until I reach the second corner frequency, that is at 5. So once I reach the second corner frequency, I need to have minus 40 decibel per decade as the slope of the line. So drawing a line which is parallel to this dotted line. Now let us go with the phase plot. This is the phase plot. Let's check with the table. The first reading of omega is 0.2. So at 0.2, let us plot the resultant angle, that is minus 13.6. So as I have put the x-axis as 0.1 here, started with a 0.1, then 1 here and 10 and then 100. So this will be the 0.2. So at 0.2, we need to plot minus 13.6 degree. So you can see that I have put the x-axis here as minus 180 degree and with 30 degree difference, that is 150 and then 120 with 30 degree difference, I have put the y-axis and exactly measuring with minus 13.6, plotting it, I get the point here, that is the first point. And next with 1, I need to plot it for minus 56.31. So 1 is here and minus 56.31 is exactly here at this particular point. So I have marked it. Similarly, plotting all the other readings, then joining all the points, this is the graph we obtained. Once the magnitude plot and phase plot is completed, we need to find out the values of WPC, GPC and PM and GM. So that is why we need to check both the plots crossing the x-axis. In the magnitude plot, we can see that at this particular point it crosses the x-axis, that is 0 decibel line. So you can clearly see at this particular point the value of omega is 5.6. So I can tell that the gain crossover frequency is 5.6 radians per second. Now with respect to the minus 180 degree line, measuring the value, that is magnitude of the phase plot, we get it as 52 degree, which is nothing but the phase margin value. So in this graph, if you observe, this value will not touch minus 180 degree line. At some infinite point, it will reach to minus 180 degree. So this graph keeps on increasing and we can tell that when it reaches that infinite point, the magnitude of this or the gain margin value right from the 0 axis, that is 0 decibel line, it would be also infinite. Now here we can observe that the value of phase margin is above minus 180 degree, which is nothing but positive. And similarly, the gain margin value is below the 0 decibel line, so it is plus infinity. So that is why when both are positive, the system is going to be stable. So these are the values which we have obtained from the graph, that is WGC is equal to 5.6 radians per second and phase margin is plus 52 degree and phase crossover frequency is plus infinity radians per second and gain margin is plus infinity decibels. So hence both are positive, system is going to be stable. Thank you for watching.